All right, welcome back to the final part of the three parts of analyzing a quadratic function. This is the function that we've been dealing with, and I just wanted to remind you what it looked like. If you're not sure where these numbers are coming from, when we start plotting them, make sure you go back and watch the first two parts, and that should explain pretty much everything you need. So we're going to graph this function now, and normally I would do this while I'm finding the other steps, because this is a nice easy way to check your work, because this parabola should be very symmetrical, and that's what we're going to start with right now, is the line of symmetry, the axis of symmetry. And if you remember correctly, that was found at x equals 1. So I'm going to draw a vertical line going through x equals 1. Now the vertex was found at 1, -1, so I'm going to put a point there. And now I'm going to plot the zeros. And the zeros of this function were 3 plus or minus radical 3 all over 3. And since those are irrational, you cannot get them exactly in the right spot. I just punched them into a calculator to get a quick estimate of where they were. So 3 plus radical 3 over 3 was about 1.6, so I'm going to put a point there. And the 3 minus radical 3 over 3 was approximately 0.42. So again, that's about as close as I'm going to be able to get. The y-intercept that we found was at 0, 2, and its reflection point was at 2, 2. So I'm going to draw a parabola through these points as close as I can. And you notice that it is very symmetrical, and so that should make you feel pretty good about all of your computations. Now I'm going to answer the final couple questions about it. And the first of those questions is, what is the domain of this quadratic function? Well, if you remember correctly, domain refers to the x values. And so we're kind of wondering, is there any x value that is not going to get hit eventually by this parabola? And if you notice, I included these arrows, and that implies that the curved line is going to continue in this direction out into infinity. And so while it may take a long time, every x value will be eventually hit. And so we're going to say the domain is all reals. If you're using set notation, that would be negative infinity all the way to positive infinity. Now another part that we want to talk about is the range. What is the range of this function? And if you remember correctly, range is referring to the y values. So the vertex is the minimum of this parabola. Now if it opened upside down, it would be the maximum. And so if we follow the curved line, we keep going up forever and ever in the y direction, but we can't get any lower than the vertex. So the range is going to be slightly different. It is not all reals. It would be y is greater than or equal to the y value of the vertex, which is -1. And if you were using set notation, that would be a square bracket, -1, all the way to positive infinity. The final two questions that I want to look at here is, where is the function f of x positive, and where is the function f of x negative? Now this can be a little confusing if you're not sure about what the question is actually asking. And what you have to understand is, when we say function, we are talking about f of x. F of x is the function, and if you remember correctly, f of x is the y values. So we're really concerned about y values being positive, and that's found in the first and second quadrant. The where in this question is referring to the x values. So what x values will return a positive y value. So you can think of a function as an input-output table, and we're just plugging in any single x value that we want, because all real x values are going to be good for us. So as we plug in these x values, is it going to return a y value that's positive or a y value that's negative? Again, y values are positive in the first and second quadrant. So as we go along, you should notice that to the left of this 0, all y values are returned positive. And to the right of this 0, all of the y values that are returned are positive. So to answer the question, where is the function positive? Well, it is positive when x is less than 3 minus radical 3 over 3, or when x is greater than 3 plus radical 3 over 3. So now we're going to look at what x values is the function negative. So which x values that we plug in return a negative y value. And negative y values are found in the fourth and third quadrants. And so if you notice, anywhere in between here, we're down in the fourth quadrant. And so any x value in between these zeros will return a negative y value. Everything right in here. So where is it the function negative? Well, when x is greater than 3 minus radical 3 over 3, and where it's less than 3 plus radical 3 over 3. So again, if you really understand your function notation and that f of x represents y, this is not a very difficult question. But if you're having a little trouble with that, maybe you're not sure. Where refers to the x values. What x values returns y values that are either negative or positive.